late Professor SKA3013 Dr. Muhammad Idris bin Saidin. My name is Kirtiwartini, daughter of Velu, and my metric number is T2019-10888512. The experiment that we selected under titration topic is titrometric analysis of calcium and magnesium in muscle. In this experiment, EDTA titration methods is used for the determination of calcium and magnesium. EDTA is the short form of ethyl and diamine tetraacetic acid. EDTA is a large molecule which creates a complex with a metal ion bonding through 6 coordination sites. In this experiment, there are two parts which are calcium determination and also magnesium determination. For the calcium determination, calcium will be precipitated with ammonium oxalate. The oxalate is destroyed by heating with perchloric acid. Then the calcium is titrated with EDTA using either alcene or calrate as the indicator. Moreover, determination of magnesium. For this, magnesium is precipitated with oxime. The oxime is destroyed by heating with perchloric acid. Then sufficient EDTA is added in the presence of either calcine or calrate until the color of indicator changes, after which the magnesium is titrated with additional EDTA using aerochrome black tea as the indicator. Aerochrome black tea is a complexometric indicator that is used in complexometric titrations. For example, titrometric analysis of calcium and magnesium in muscle. In its protonated form, aerochrome black tea is blue. It turns red when it forms a complex with calcium, magnesium or other metal ions. The molecular formula of aerochrome black tea is C20H12N3NaO7S. The appearance of the aerochrome black tea is in a black powder. When aerochrome black tea is used as an indicator in an EDTA titration, the characteristic blue endpoint is reached when sufficient EDTA is added and the metal ions bound to the indicator are chelated by EDTA, leaving the free indicator molecule. That's all for the introduction. Now I'm going to talk about the objective of this report. There are few objectives I used to complete the report of this experiment. They are: the first objective is to analyze calcium in muscle using EDTA titration. There are few steps used in this experiment to analyze calcium, where calcium is precipitated with ammonium oxalate. By heating with perchloric acid, the oxalate is destroyed. Then, with EDTA, the calcium is titrated using either calcine or calrate as the indicator. The second objective of this report is to analyze magnesium in muscle using EDTA titration. As calcium, for magnesium analysis also, there are few steps used in this experiment where magnesium is precipitated with oxime. By heating with perchloric acid, the oxime is destroyed. Then, in the presence of either calcine or calrate, sufficient EDTA is added until the color of the indicator changes, after which the magnesium is titrated with additional EDTA using aerochrome black tea as the indicator. The third objective of this report is to study about the ethylene diamine tetraacetic acid, EDTA, and its function. Ethylene diamine tetraacetic acid, EDTA, is a large molecule which have bonding through 6 coordination sites and creates a complex with a metal ion such as calcium and also magnesium. Ethylene diamine tetraacetic acid is an aminopolycarboxylic acid with the formula of CH2 and CH2CO2H22. EDTA is a white and water-soluble solid which is widely used to bind to iron and calcium ions. It binds these ions as an hexadentate chelating agent. The last objective of this report is to obtain the endpoint. Endpoint is a point in a titration at which a reaction is complete and often marked by a color change. In other words, it also can define as a point that marks the completion of a process or stage of a process especially. Now, I will be showing you the flowchart, which is the simplest form of the methods used in this experiment.
Hi everyone, my name is Novatin Dayana binti Isham. So today I will explain about methodology. In this experiment, there are two determinations. The first one is calcium determination and the second one is magnesium determination. Okay, firstly, ash muscle was at 500 degrees Celsius, 400 to 1000 mg weight overnight in platinum crucible. Then ash was washed into centrifuge tube with 0.5 ml of 1 Newton HCl. 2 drops of metal rate indicator were added and then 1 Newton NH4OH was added row-wise until the color changes to yellow. Crucible was washed completely into centrifuge tube with 3 ml of 0.07 Newton acetic acid. 1 ml of the ammonium oxalate solution was added. The precipitate was allowed to form overnight. The supernatant was centrifuged 3000 rpm 10 minutes and carefully removed. The precipitate was dried by gentle warming and 1 drop of 70% perchloric acid was added. The tube was lowered slowly into metal shield embedded in a sand bath hot enough so that the top part of the tube was at least 200 degrees Celsius. After the white perchloric acid fume ceased to appear, tube from sand bath was removed and the residue was dissolved in 2 drops of 3 Newton HCl. 1 ml of 3 Newton KOH and 1 drop of calcium or carate were added. The residue was titrated with 2 millimolar ETA to the appropriate change. In reading endpoint, the total volume should be 2 ml or more. Water was added if necessary. The endpoint was compared with blank. Lastly, the residue was back titration with 2 millimolar calcium standard. For magnesium determination, firstly ash muscle about 200 mg weight as above. Then ash was washed into centrifuge tube with 0.5 ml of 1 Newton HCl and 1 ml of water. Then 0.5 ml of ozone and 0.5 ml of concentrated NH4OH were added and precipitate was allowed to form overnight. The precipitate was centrifuged and oxidized with perchloric acid as above. If color was not completely destroyed, perchloric acid treatment was repeated. Residue was dissolved in 2 drops of 3 Newton HCl, 1 ml of 3 Newton KOH, and 1 drop of calcium or carate were added. 2 millimolar ETA was added until the color just changed. Water was added if necessary to make volume of 2 ml. The residue was compared with land. The critical step was to adjust the endpoint. It was sometimes made easier by using the 2 millimolar calcium solution. The pH was readjusted to 10 with addition of 1 ml of cool ammonium chloride, ammonium hydroxide buffer followed by 1 ml of 3 Newton HCl. Then 1 drop of aerochrome black tea was added and titrated with 2 millimolar ETA. Then lastly, the endpoint was compared with length. For back titration, either the 2 millimolar calcium or magnesium standard may be used. Okay, so this is the result for calcium determination and magnesium determination. There are a number of determination, micromoles in sample, calcium magnesium, where the ratio is 1 to 10 and 10 to 1. Then the average micromoles calcium recovered and standard deviation of sample for calcium determination. For magnesium determination, there are also number of determination, micromoles in sample, magnesium calcium, where the ratio is also 1 to 10 and 10 to 1, the average micromole magnesium recovered, and lastly, the standard deviation of sample for magnesium determination. Okay. For discussion, the tables before show calcium and magnesium recoveries. Calcium-magnesium ratio are 1 to 10 and 10 to 1. Based on the tables, there appeared no significant reciprocal interference in either determination. A pool of several muscle was etched and dissolved in 1 Newton HCl to test possible interference. Concentration of calcium in muscle ash solution is 2.60 plus minus 0.01 millimolar in 18 determination and 15.18 plus minus 0.09 millimolar for magnesium in 16 determination. Known amount of calcium and magnesium were added to muscle ash solution and were recovered. Excess perchloric acid should be removed completely to avoid insoluble potassium perchlorate formed upon ROH addition. Cyanide has been recommended to remove interfering cation for ETA titration using aerochrome black tea, calcine, and carate. Addition of 0.5 Newton potassium cyanide to some muscle ash solution is superior to addition of calcine or carate indicator. It did not change calcium and magnesium values. Determination were made on individual skeletal muscle from 13 frogs. Calcium was found 1.68 plus minus 0.07 millimoles per kilogram weight and 8.84 plus minus 0.31 millimoles per kilogram weight for magnesium. Magnesium calcium ratio is 5.26. The correlation coefficient is 0.79 with probability value of 0.1%. These findings are reasonable agreement with previously reported values for frog's muscle, calcium 5.8 and magnesium 8. Okay, that's all from me. Thank you.
Hi and hello everyone. My name is Ranjida, daughter of Satyasilan. My metric number is D2019-1088518. As a conclusion, calcium and magnesium in muscle determined using the EDTA titration method. At the end of the experiment, we can conclude the EDTA is a large molecule which form a complex with calcium and magnesium ions. Calcium is precipitated with ammonium oxalate. The oxalate is destroyed by heating the perchloric acid and the calcium is titrated with EDTA using either calcine or chlorate as the indicator. Magnesium is precipitated with oxine. The oxine is destroyed by heating the perchloric acid. Then sufficient EDTA is added in the presence of either calcine or chlorate until the color of the indicator changes. Then the magnesium titrated with additional EDTA using aerochrome black tea as the indicator. The blue dye called aerochrome black tea, aereo tea, which used in the experiment is an indicator. This blue dye also forms a complex with the calcium and magnesium ions, changing color from blue to pink in the process. At the end of the experiment, we also understood about the endpoint, which is one of the most important things in titration. We are able to observe the color change of the indicator when the solution reaches endpoint. Thank you.